All right, guys. So I'm Rohit Thakur. I'm with Synchron, and I lead the innovation team. Okay, and I'm here to talk to you about the new LLMs that are coming in, basically the reasoning models that are coming in. Okay, so I want to start off by telling you some history of how we got here. Okay, so back around in 2017. Okay, Ashish Vaswani from Google released a paper. Okay, it was Attention is All You Need, that introduced transformer architecture. It introduced a lot of things, and we got away with using LSTMs, RNNs for language encoding. After that, we had BERT coming in. We had OpenAI's GPT coming in. That sort of changed the whole landscape of moving from labeled tasks to next word predictions. Okay, and then we had larger models, we had larger data sets and larger compute. Then what was introduced by GPT 3.5 was reinforcement learning with human feedback, wherein a model was just trained for preference tuning. Yeah, I mean, it could generate an output the way you want it to, and that is what sort of set the stage of what we are doing today. All the work that is being done in NLP somewhere revolves around using LLMs, and that is what we're going to talk about today. All right, okay. So what is next word prediction? Why does it work? Now, next word prediction is just you want an LLM to predict the next word given a context of window. Okay, and why does it work? Because a lot of tasks that we have in NLP today can be formatted in a way that it is next word prediction. Like if you look at the first sentence, in my free time, I like to, and then there are two options, run and banana. Obviously, we know the answer should be run. So here, the model is learning just grammar, what the basic grammar and what the lexical knowledge of a LLM is. The second sentence, I went to a zoo and I see giraffes, lions, and again, you have two options. You have zebras, you have spoon. Here, the obvious answer is zebra. So again, lexical semantics. If you go to the third sentence, the capital of Denmark is Copenhagen or London. The answer is Copenhagen, and you learn about world knowledge here. So there are a lot of tasks in NLP that we had to train a lot of models for in the past that can be done in a next word prediction paradigm. Okay? And that is why next word prediction works really well in these tasks. Now, okay. So there's one problem with next word prediction. Obviously, it allows you to do some sort of in-context learning. In-context learning only happens at scale. That is, you can let your model learn new stuff without wanting to retrain it or without needing to retrain it. Okay? But not all the tokens provide the same amount of information. They don't have the same amount of token density. Okay? So what I mean by that? Now here, when I talk about prediction difficulty, look at the first sentence. Hi, nice to meet, and then dash, you need to predict what the next word would be. I think it would be you, and it's fairly easy to predict that word. If we go to the next one, my favorite color is dash. Now it's a little difficult. It could be any color. We don't really know. So the information density in the first token and in the second token is really different. Okay? And when we go to the third one, what is the answer to? There's a mathematical equation. You cannot really just give an answer outright. You will have to do some work. You'll have to use some formulas, and then you can arrive at the answer. So what I'm trying to tell you here is not all tokens have the same amount of information density. Some might need a lot more work than the others. One of the approaches that were developed in order to solve this is something that we call chain of thought reasoning. Here's an example of chain of thought reasoning where you go from just getting the answer outright, then so the LLM shows it work of how it arrived at the answer. So if you look at the first example that I have here, okay, it's about tennis ball, and you get the answer. Answer is 11. The second question, and then a lot of thinking is required to use these models. And in the second one, where we're trying to do chain of thought prompting, we get to see the thought process of how the LLM arrived at the answer, and it was sort of able to get the answer right. Now, this is what we are doing with chat models, but what is the problem here? There's one basic problem with this, and the problem is that LLM that were trained just a next word prediction are not really optimized to do these kinds of thinking. They did, I mean, the LLMs obviously got the answer right, but they sort of emulated what the reasoning would be, okay? And they're not really doing the reasoning as such. So we move on to our solution to this. We have new models that are coming in. I'm sure a lot of you might have seen this graph. It's for Deepseek R1, where they claim that they beat a lot of, I mean, they have just crushed the benchmarks when they sort of tried it against OpenAI's O1 models. We also have Gemini's model that does some sort of reasoning. There's not a lot of documentation on that, so that is why it's not included here. And O3 Mini, I think, has been released like a few days ago, so that is why it's not in this. But yeah, so we're primarily going to talk about Deepseek R1 because that is open source and that is the only information that we have on how these models were trained. Okay, so let's talk about Deepseek. How it is trained, why does it work so well? It was majorly scaled on reinforcement learning, okay? Reinforcement learning was used to sort of teach it how to think. It was done through something called GRPO. And what it did was there were a lot of chain of thoughts that were given to Deepseek, okay? And it had to just predict what the right chain of thought would be and arrive at the answer. It got a reward at the end of the answers that were coming in. Okay, I'll just walk you through this one GRPO thing. Okay, so this is the GRPO question. It is daunting as such, but I'm going to explain this. I'm going to break it down one by one. All right, so let's look at the first part. You have two things here. You have your question and you have your answer. Your questions are being sampled from a distribution and your answers are being sampled from one distribution. We are going to sample a lot of answers. I think it was 64 answers that were sampled for every question. So what the next step was to just calculate the amount of reward that you would get given your new answers that are coming in, okay, basis the older reward. So if your new predictions are better than the older predictions, you get a reward for that. Next, once we have that reward, we want the model to learn, but we also want it to be very stable. We don't want it to be all over the place. So we introduce a clipping function there where we set a threshold, and the reward can only be always in that threshold, okay? Then we talk about advantage. So advantage is more of a normalizing factor that we have to these rewards that were calculated in step 2. And then we move to KL divergence. So what we're trying to do here is all the answers that we're getting, okay, we don't want them to be very different from what the base model was already trained on. And sort of what we try to do is the people in Deepseek, they've used KL divergence in order to regularize the training process, and that is how GRPO sort of works. Now, how do you use these models? Can you just change the model name in your pipeline and then sort of start working this? Actually, no. There is one caveat here. You cannot just straight away go around and using those models, okay? So there's a very famous tweet from Ben Hilak. This was back in December when O1 was released, okay? And he said that O1 model is really bad. It does not really perform well. It does not really work that much. And that was sort of the scene when O1 was released. Okay, so let's talk about what Ben Hilak was doing that sort of OpenAI believes that is wrong. And there is this one very famous blog which is called O1 isn't chat model, and that's the point. If you see, they've mentioned the changes in prompt that they did in order to get a lot more from O1. And that is, the one difference that we have here is you'll notice there's no persona here. They've not written any instructions on how to arrive at the answer, okay? What they do tell is what the goal of the task is, what the return format needs to be, and they've done a lot of context dumping. Obviously relevant context, but nowhere in this prompt is written on how you need to arrive at the answer. And that is the key part here, because the prompt that you write for O1 is very different from the prompt that you write for chat models, the basic chat models that we have. And obviously, after a few months when this was revealed that you need to sort of change the way you prompt these models is different, there is this another tweet which Ben highlighted, and Sam Altman sort of seconded that. Uh, so we'll just move to, I'll give you an example of one of my use cases that I've worked on. We work for a car manufacturing company, and there was, we had to build chatbot, okay, and this was a base data, wherein we had to do a lot of calculations. So these were engineers who were using this chatbots, and they used to ask a lot of technical questions where a lot of calculations were needed, okay? So this is the base data, okay? And we are going to, so the question was, give me the car model that has its kilowatt power in between some 130 to 150. This is the question. The right answer here obviously is GLC 22D4 Matic, okay? So when we use a normal prompt that is meant for the chat models, we get this output, but because there was some amount of calculation that was needed, it got it wrong. It said both the models have these specifications. Now, obviously, this is a one-off example, but this is sort of, I'm trying to make a point here. So once we changed a prompt to what the reasoning model expects it to be, okay, we sort of got the right answer. If you see here, it's GLC 22D4 Matic, and that is what you need to do in order to use these reasoning models. And okay, so let's talk about performance and cost statistics. Now, reasoning models spend a lot of time thinking about the answer than giving you the answer directly, and obviously that includes your latency. This is from artificial analysis, and we look at the first graph for latency, okay? If you see Deepseek R1 and O1, if you compare these to all the three chat models that we have, chat models sort of bring out the answer really quickly, whereas the reasoning models try to think about what the answer should be, and what needs to be done. And that is why the latency will always be on the higher side. We go to the second slide, which is quality versus pricing. If you see, we have O1 and Deepseek R1. The pricing for these two models are obviously going to be higher because you need a lot of tokens to accomplish reasoning tasks than you need to do chat, than you need with chat tasks. O3 Mini would somewhere be near Deepseek R1 because it's really reasonable priced. So that is why we believe that it needs to be somewhere near Deepseek R1. But the takeaway here is just that you'll have a lot of latency with chat models, and you have better quality of outputs, but that comes at a cost. So you will need to sort of verify if your task needs that amount of reasoning, and if you're willing to pay that price. Okay, so there's one important thing that I want to talk about is when not to use these reasoning models. First one, obviously, is when you have a workflow that has a lot of function calling. Now, in DeepSeek's paper, they mentioned that they have not trained Deepseek R1 to do function calling, but there are ways to sort of invoke it. We don't recommend doing that because they have a lot of thinking process that goes under before they output their official answer, okay? And that is why function calling and all the other multi-turn conversation, complex role-playing, and JSON output generation will take a lot of time than using a regular model. Obviously, this could be optimized further, but right now, this is the scene. And okay, the second thing is Deepseek R1 and reasoning models are very sensitive to prompt change. If you change one aspect of the prompt, it will change the output a lot. So that is why if you have a use case where you want the prompt to be, you have the prompt and it's being filled in by some context or something, it wouldn't really be a right task for the reasoning model to do. And the third one is it's not really optimized for software engineering tasks. I think O1 is optimized, it writes really well code, but Deepseek R1 is not. Okay, so that is one thing. Let's move on. I'll just summarize the entire thing here. This is from the LangChain blog. Okay, so in summary, the chat models, the scaling paradigm for the chat models is next word prediction, whereas for reasoning models, it is reinforcement learning on chain of thought. Okay, when you go to reasoning type, it has system one thinking, and system one thinking just means that it's really fast, it's really innovative. So like if I have to give you an example, if I ask you what is 2 plus 2, you would say 4. You wouldn't really think about what the answer is, and that sort of is what system 1 thinking is. The second, reasoning models are system 2 thinking. It's really slow, it's really effortful, and that is why they take a lot of time to do that. When you talk about prompt, you need to tell chat models of how you need to arrive at the answer. You need to think step by step. When you go to reasoning models, you just need to tell it the output that you want and give it some context on how the answer should come. You really need not tell it, you really need not give it instructions as such. Interaction is very interactive, obviously because chat purposes, and for reasoning models, it sort of works in background. I mean, if you have any task that needs to be done in background, you could use it to the. Sorry. Yeah, thank you so much.
Check. Thank you so much, Rohit. Wonderful session there. Ladies and gentlemen, questions here for Rohit before we move on to our next session. Can we have a mic there with Sir in blue shirt quickly, please?
Hello. Really insightful session. So there is a lot of talk about agentic AI. So as you said, there are many cons of using Deepseek, like it is slow and all these, we don't know what is happening within it, okay? So using agentic AI, can't we have an agent which reasons for us in the existing ecosystem?
You can, okay, obviously you can. The only part that you need to worry about is latency because the reasoning part will take a lot of time, okay? But if an agent, all that it does is just do reasoning, I think you're better off not doing with the agent and using the model.